We often think of science as this giant fortress, right? Built on the solid, unbreakable rock of absolute proof. But what if I told you the real foundation of science is something, well, a lot more dynamic and honestly, way more interesting? Today, we're going to explore why the constant process of justification is actually more critical to scientific progress than the hunt for some final, unshakable truth. So, here's our game plan. First, we're going to peel back the layers and look at what science really stands on. Then, we'll figure out what sufficient grounds even means. After that, we'll put justification and proof in the ring together. And finally, we'll see why the method of science is its real secret sauce.
All right, let's dive right in at the deep end. What is actually holding up this massive structure we call scientific knowledge? I think the answer is going to surprise you.
So let me just ask the question outright. What is the true foundation of science? Is it just a big library of facts that have been proven? Or is it something more alive, something that's fundamental to how we even think? Okay, so this right here, this gets to the heart of a huge misunderstanding. The common assumption is that science is all about absolute proof, but the reality, the scientific reality, is that it's a constant active search for what we call sufficient grounds. It's a process, not a destination. To really wrap our heads around this, let's use an analogy that we're going to come back to. I want you to imagine all of scientific knowledge as a massive skyscraper. Now, before you can build up story after story, you have to do something absolutely critical first. You have to know what that entire thing is resting on. And that brings us to the star of our show today, justification. Now, the source material for this uses the Russian term Abbas Navan, and it calls it the single most important requirement of scientific thinking. It's not just an option, it's the whole game. It's this ongoing critical reflection on the very essence of a claim. And hey, this isn't some newfangled idea. The philosopher Hegel pointed this out a long time ago. He said scientific thought can only operate on what's derived from foundations. You can't just have these ideas floating around in the air. And that act of finding and checking those foundations, well, that's justification. So, okay, if justification is this big search for foundations, what exactly are we looking for? How do we find that bedrock for a skyscraper? This is where the idea of sufficient grounds comes in. What we're after is what are called sufficient grounds. This is just a way of saying the evidence and the reasoning that you bring to the table to back up a claim. See, it's not enough to just say what you think is true. You have to show why it's reasonable for anyone to believe it. Now, these grounds, they basically come in two main flavors. On one hand, you have empirical grounds. This is stuff based on direct experience. You go outside, feel the sun on your skin, and you say, the sun warms. Simple, direct. But then you have theoretical grounds, which go a step further. This is where you use data and logic to explain the why. The physics of nuclear fusion that explains why the sun warms. Science needs both to build a sturdy structure. And we built these grounds using a few key tools from our mental toolkit. We're always trying to indicate the cause, figure out the cause and effect. We use induction, which is just gathering a bunch of facts and seeing what general conclusion they point to. And we use logical inference to make sure all the pieces fit together without any contradictions. Okay. This brings us to a really, really important distinction. We've talked about justification and finding grounds, so where does proof fit into all of this? Because as we're about to see, they are not the same thing. Not at all. This table just lays it out perfectly. Just look at that first row. Necessity. Justification is obligatory. It's essential. You have to do it. Proof? Well, proof is great to have, but it's not always necessary or even possible. Let's go back to our skyscraper. Justification is the act of digging for bedrock. Proof is like showing up with the flawless, perfect architectural blueprints. You have to dig for bedrock every single time, but you don't always have those perfect blueprints on day one. Both of these ideas, justification and proof, they fall under this bigger umbrella called argumentation. It's really just the art of providing grounds for your thoughts in a way that's convincing. It's the engine of all scientific debate. And here's how that whole structure gets built. Step 1, the foundation is always justification. It's non-negotiable. From there, you build up your argument, you use logic to make sure it's airtight, and then, way up at the top, as the absolute strongest outcome you can hope for, you might achieve logical proof. Proof is the peak of the mountain, but justification is the mandatory first step of the climb. So, what does this all mean for how we think about truth? If science is really built on this ongoing process of justification instead of just collecting absolute proofs, it completely changes the game. It shifts our focus from the destination to the journey itself.
And this, right here, this is the big takeaway. The reason science is so incredibly reliable isn't because it has a monopoly on some final absolute truth. No, its power comes from its relentless commitment to a method that is transparent, that is repeatable, and that anyone can check. That's the real magic.
So where does logic fit in? Think of logic as the official rulebook for the whole process. It's the set of tools we use to make sure our arguments are consistent and don't contradict themselves. And why does that matter so much? Because a theory that's logically sound, that doesn't contradict itself, is describing at the very least a possible reality, a model of the world that could actually exist. So let's go back to our skyscraper one last time to really lock this in. Justification is that essential, mandatory work of digging to find solid bedrock. Proof is the ideal outcome. It's having the perfect, flawless blueprints that guarantee your building will stand forever. Science demands that we always dig, that we always justify. It hopes for those perfect blueprints, but it runs on the hard, critical work of checking the foundation over and over again. This really reframes how we should see scientific progress, doesn't it? It's not just about finding answers. It's about building strong, reliable foundations for the questions of tomorrow. Which kind of leaves us with one final thought to chew on. If this is what science is, this constant method of justification, what are the great questions in AI, in climate science, in cosmology, that we're digging the foundations for right now?